टेस्ट टाइम के ऊपर रिसीव करने के लिए। टेस्टिंग से पहले बाउंड्री तो डिसाइड हो चुकी है, W तो डिसाइड हो चुका है, और अगर वो W आउटलायर से सेंसिटिव था वो बहुत बुरी डिसाइड हो चुकी है बाउंड्री। मेक सेंस? अब रेंज को ऊपर नीचे करने से, डिसाइड करने से ये किस्म है, बिकॉज बाउंड्री इज डिसाइडेड इन अ वेरी रॉन्ग वे, यू आर ऑल, आई मीन मोस्टली you will be misclassifying things. Yes, and that's a standard problem with this linear regression using this least square.
ऐसा फिर क्या कोई तरीका होना चाहिए कि इसमें आउटलायर्स को उठा के बाहर फेंक दें?
Yes.
So मतलब deep pre-processing चाहिए डाटा का।
Sorry?
इसका मतलब है डाटा में deep pre-processing करेंगे।
So one way is to remove the outliers using pre-processing, and the other way is to deploy algorithms that are less sensitive to outliers. So I am going to discuss one of the algorithms today, not completely, just to introduce that logistic regression that is less sensitive to outliers as compared to the ordinary least squares. Clear? And there are ways to remove the outliers as well. By the way, just to bring your attention, there are some definitions of outliers. With respect to those definitions, you can remove the outlier by using them. There are some assumptions that this kind of point is known as an outlier. Then there are algorithms to remove those kind of outliers. I mean, outlier can be defined in a very weird way and then you can run with it. Make sense? There are some standard way of defining outliers that this kind of point will be an outlier, this kind of point will be an outlier. So these kind of algorithms will remove outliers. Okay? And the algorithm I'm going to discuss right now is a different than linear regression. It looks like the same but very different and it is less sensitive to outliers. It is not completely insensitive to outliers. It is sensitive to outliers but in a very minor way. Make sense? So let me discuss that. Is that okay? Yes, no? Yes. By the way, ये वैल्यू रिस्ट्रिक्ट नहीं हो रही थी 0 से 1 के दरमियान, ये यहाँ पे जब आप ट्रेनिंग कर रहे थे तो इस वैल्यू को आप कोई किसी एक बाउंड्री के अंदर रिस्ट्रिक्ट नहीं कर रहे थे। यस, ये रिस्ट्रिक्ट नहीं कर रही है, वैल्यू अगर आ रही है बिलफर्ज, ये वैल्यू आ रही है 1000 और ये आ सकती है, ठीक, और इसका लेबल था 1000 minus 1 that is 999 और इसका square that's the error. Obviously this point is an outlier and it is causing big trouble because it is moving away from this thing, and the square of that is big. What if somehow at the training time somehow we force this number should not go out of the range? ये जो number generate हो रहा है W transpose X, it should stay, that result should stay between 0 and 1. So that its distance from 1 or 0 is not very large, and so the square of it is not extremely large. Make sense? Yes, we can do that. And here is how we do that. Should I erase this?
सर ये sigmoid पे इसको verify करने के लिए हम try करते हैं.
Yes. This is one way of doing it. There are several others. And by the way, ये जो मैं आपको बताने जा रहा हूँ, this is one of the most popular algorithms, logistic regression. इससे एक और भी पॉपुलर है, इसलिए हम उसको देखेंगे चलो अपने तफसील के साथ, but this is, I mean, equally most important. By the way, if you're lost in math, outliers and stuff, it's understandable. But hold on, when we code it in the next lecture, inshallah, we will see the details of it and everything. And I have already written the code that I will supply you in the next lab, not today. I've already written a code for this. When you write that, you will see the stuff, things will become very, very clear to you, inshallah. Clear? Abhi, अगर मज़ीद थोड़ी सी मैथ लिखने जाऊँ, that's okay. That's required. Okay, here is how we will restrict this number to stay in the range of the labels. Okay? And the labels are 0, 1, 0, 1. Okay? 0 and 1. So class 1 labels 1, rest of the classes label 0. For binary classification, class 1 label 1, the other class label 0. So here is the technique. Class 1 label 1, rest of the classes label 0. ये लीनियर रिग्रेशन में हमें फर्क तरह से किया था। लीनियर रिग्रेशन में हमने क्लास 1 को 0 का, इट डजंट मैटर, बस थ्रेशोल्ड का साइन ऊपर नीचे चला जाएगा। आप इस तरह से लेबल ऐसे करते हैं, तो जो थ्रेशोल्ड आप ग्रेटर देन 0 पे करते हैं, लेस देन 0 पर फर्क लगाने, इट डजंट मैटर। जस्ट ये मैं इसलिए कर रहा हूं टू असाइन द प्रोबेबिलिटी, बट एनीवे this is class 1, this is rest of the classes which is 0. So this is class 2, 3 and 26. I am learning W1. So here what I will do, J varies, okay, I varies from 1 to n, 1 over n, that is the error function, plus lambda W transpose W. I will call this lambda by n just to. Obviously here is we have our famous yi, and here is the square. Somehow I want to restrict this number so that it does not go very far away from this, and then the square of it just blows out. Okay? And why not at the learning time I deploy this. Make sense?
Yes.
Now this number is guaranteed to stay in the range. No matter what W you come up with, no matter how long an x is placed, the value will be between 0 and 1. So this kind of strategy makes this algorithm less sensitive. Just this thing, less sensitive to outliers. Make sense? This solution comes with a problem. The problem is this function is not convex, which means what? In the case of linear regression, if you deploy this, the function was having a bowl shape, which means you take the derivative, you put it equal to 0, you find out a value of W where the global minimum exists. Make sense? And the convex function is of this shape. It do not go this and that. No, that's not convex. Once we use this thing inside, minus this whole function was convex. We take the derivative, we put it equal to 0, and we find out the W, and we are sure this W is the global minimum. There is no other W for which the error goes down than this. Make sense? This function is not convex, which means this. It has several minimums, several maximums. This is the minimum, 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 this is the minimum. Oh, by the way, maximum, maximum. This is the minimum, this is maximum, minimum, maximum. So, I guess this is the global minimum. Yes?
Yes.
But once we differentiate this and find out the W's where the derivative is 0, we will find out several of such possibilities, candidate ones. Make sense? इधर ध्यान से सुनिएगा, मैं अभी थोड़ी देर बाद क्लोज कर दूंगा डिस्कशन, लेकिन ये एंड वाली डिस्कशन का बहुत सा सुनिएगा. This function is non convex, which means there are several minimums. Assuming कि हमारे पास कोई second derivative test है, जो अगर मैं W आपको बताऊं तो बताएगा कि ये local minimum है, ये local maximum है. Assume that हमारे पास second derivative test ये बता देता है कि ये minimum है, ये maximum. This is local minimum, this is local maximum, this is local minimum, this is local maximum, so on. Local क्यों है? क्योंकि जब आप derivative ले रहे होते हैं, you're seeing very locally whatever minimum or maximum you come up with, it is based on a very local vision. That's why that's local minimum or local maximum. It is not seeing the function overall. Make sense? So now, अगर आप इसका derivative लें, इसको 0 पे equal put करें, you will find out several candidate W's. W1, which is a vector, W2, which is a vector. All of these have derivative 0. Yes? So which one is the global minimum? Assuming कि आपने जो local maximum वाले हैं वो discard कर दें, there is a way to discard them. Let's say. So now let's say you have 1, 2, 3, 4, 5, and 6. You have 6 W's, candidate ones, and you want to find out which one of them is
The
the
global.
global minimum. The answer is very simple. You come up with this W and you plug in. By the way, इस error function में इस W के अलावा हर चीज given है. इसमें सिर्फ W given नहीं है. अगर मैं इसमें W plug in कर दूँ ये एक नंबर आ जाएगा तो 0.7 या कुछ. इस पूरे लूप के अंदर xi भी given है, yi भी given है, and lambda chosen है. सिर्फ मैं W लगा दूँ तो this thing will become a number. Yes, the error for that W. अच्छा मैं वो W1 plug in करता हूँ कोई error आ जाएगा, मैं W2 plug in करता हूँ उसमें कोई error आ जाएगा. मैं देखता हूँ किस W पे error minimum है मेरा global minimum. सही है? बड़ा आसान लग रहा है. लेकिन ये तब है जब आप मुझे इस सवाल का जवाब देने के बाद लिखेगा. इधर आप देखिएगा. अगर मैं आपसे कहूँ W और ये W के लिए नंबर है. Wx plus 2y is equal to 0. What is the value of W? इस इक्वेशन को सॉल्व करें तो W की वैल्यू क्या है? Very simple. It is minus 2y over x. That's the value. Found very easy. Yes? Wow. Okay. Now we have W square x plus e raised to the power wx over minus w plus 3y x is equal to 0. Find out w. W की वैल्यू क्या है? W की वैल्यू क्या है? Okay, so here W cannot be separated. Cannot be. So number one, if we just try to solve a problem that is less sensitive to outliers, give it the range and stuff, then this function is non-convex. Even if it is non-convex, we might have to try to solve it by iterating over all possible candidates of W and give whatever gives the minimum value. But that requires W equals to something should be solved by the iterator. इसका अगर मैं डेरिवेटिव लूँ और उसको 0 इक्वल प्रूव करूँ और बाद में W की वैल्यू निकालना चाहूँ, W is not separated. समझ आ रही? यानी W की वैल्यू is equal to something that is not W, that does not contain W, is not possible here. So मेरे पास वो कैंडिडेट W's आने ही नहीं है. देखिए ना, मैं इसका पूरी का डेरिवेटिव लेता हूँ, उसको 0 पर इक्वल प्रूव करता हूँ, तो फिर W की वैल्यू निकालूंगा ना जहाँ पे डेरिवेटिव 0 आता है. That W is not solvable here. It was solvable here. Number one, it is not convex. Number two, चलो ये convex नहीं है. Let's find out the total number of W's, the total number of points where the derivative becomes 0. If they are finite, then there is a hope. Let's try one by one all of them and see where the error is minimum. So यहाँ पे derivative लेने के बाद W की वैल्यू वो नहीं निकलनी और ये convex भी नहीं है. लेकिन ये formulation is going to solve the problems that were there in the linear regression. Make sense? Now in the next lecture we are very ready for logistic regression. So very beautiful formulation that actually changes the error function. और ये पहली दफा आप देखेंगे जब आप squared error यूज नहीं कर रहे हैं. मैंने आपको बताया था you can choose this error measure or that error measure. So next time I will introduce another error measure. Rather, I will not take the square error. I will use the other error measure, and the whole story just collapsed to very simple. Make sense? So Tuesday, inshallah. Okay, I will be seeing you in the lab after 5 minutes.